Hello friends, last time we saw general equation of a line to be converted into various forms. We saw the lines to be converted into slope-intercept form and intercept form, and from that we had derived the formula to calculate the slope x-intercept and y-intercept, which depends on the coefficient of x and coefficient of y as well as the constant term respectively, which were incorporated in our slope x-intercept and y-intercept formula. So going further, we have one more form of line, which is normal form of line, and today we are going to see the general equation of the line to be converted into normal form, and we'll see the examples how we can convert our general equation of the line to all the three forms, which is slope intercept form as well as normal form. So continuing from the last lecture where we saw the two forms of lines, here we'll derive the formula to convert our general equation of the line to the third form. So I'll write third form, which is the normal form. Now we all know that the normal form or the equation of the line in the normal form is x cos alpha plus y sin alpha is equal to t. We had already seen how we had derived this formula and what each of the constant or variables in this equation, that is alpha, p, x and y, stands for. Here alpha is the angle which the perpendicular makes with the positive direction of x axis to the line, and p is the perpendicular distance of the required equation of the line, required line from the origin. Now let's say the general equation of the line is ax plus by plus c is equal to 0. Now comparing both these equations, that is normal form of equation and the general equation, we can say that a upon cos alpha is equal to b upon sin alpha, and converting our normal form, I can write that this can be written as x cos alpha plus y sin alpha minus p is equal to 0. So again, doing the comparison, I can say that c upon minus p, that is a upon cos alpha, is equal to b upon sin alpha is equal to c upon minus p. Now from this equation I can say that cos, or rather I'll first take these two sides of the equation, that is a upon cos alpha is equal to c upon minus p, as well as I can say that b upon sin alpha is equal to capital C upon minus p. From this, what I'll do, I'll reciprocate both sides of the equation, and I can say that, right, and over here I can say that cos alpha upon capital A is equal to minus small p upon capital C, and similarly I can say that sin alpha upon B is equal to small p upon capital C. So further to this, I can say that cos of alpha is equal to multiplying both the side by a, I can say that minus of p into a upon c is equal to cos alpha, and sin alpha multiplying both sides by b, I can say that minus of p into b upon c is equal to sin alpha. Now squaring on both the sides, I can say that squaring on both the sides, I can say that cos square alpha is equal to p square a square upon c square, as squaring on both the sides will remove the minus sign over here. Similarly, squaring on both the sides in this equation, that is sin alpha is equal to minus p into b upon c, will remove the negative sign over here since we are squaring, and sin square alpha is equal to p square b square upon c square. Now what I'll do, I'll add this equation and this equation. I'll get, adding LHS cos square alpha plus sin square alpha is equal to adding the RHS, that is P square into A square upon C square plus P square B square upon C square. Now we know that cos square alpha plus sin square alpha is equal to 1. So what I'll do, I'll substitute, or I put the value 1 instead of cos square alpha plus sin square alpha. So the equation becomes 1 is equal to P square into A square upon C square plus P square into B square upon C square. Now I can see that P square upon C square are common in both the terms. So our equation becomes, let me put in this way, this implies 1 is equal to P square upon C square into A square plus B square. So further I can write it in this way, that is P square upon C square into A square plus B square is equal to 1, which further can be written as P square is equal to C square upon A square plus B square. Removing square or taking square root on both the sides will give me P is equal to plus or minus of C upon whole under root of A square plus B square. Now since we have taken square root on both the sides, we will get plus and minus both the entities pertaining to the values of C and A and B. But we know that P is the perpendicular distance from the origin to the required line, and hence it cannot have the negative values. So our P becomes C upon under root of A square plus B square. Now substituting this value of P equal to C upon under root of A square plus B square in this equation, that is cos alpha is equal to minus of P into A by C, and sin alpha is equal to minus of P into B by C. We will get cos alpha is equal to minus of A upon C into C upon under root of A square plus B square, and sin alpha is equal to minus of B upon C into C upon under root of A square plus B square. C and C get cancelled out from both denominator and numerator in both these expressions. So we'll get cos of alpha is equal to minus of A upon under root of A square plus B square, and sin of alpha is equal to minus of B upon under root of A square plus B square. Now substituting these values of P is equal to C upon under root of A square plus B square, and cos alpha is equal to minus A upon under root of A square plus B square, and sin alpha is equal to minus B upon under root of A square plus B square in normal form of the equation, which is this one. We will get x cos alpha, that is equal to minus of A upon under root of A square plus B square plus y of, substitute the value of sin alpha, that is minus B upon under root of A square plus B square minus of C. We will substitute the value of P as well, that is equal to minus of C upon under root of A square plus B square. This all is equal to 0. Further to which we can say that minus of A upon under root of A square plus B square into x minus of B upon whole under root of A square plus B square into y is equal to C upon whole under root of A square plus B square. So friends, this is the final form of conversion of general equation of our line into its normal form. Now over here I like to ponder upon certain steps to transform general equation into its normal equation. The first step is shift the constant term on RHS and make it positive. Whenever we are provided general equation of a line, we need to first shift the constant term on RHS and make it positive. And second step is divide both sides. Once the first step is executed, we need to perform the second step, that is divide both sides by whole of under root coefficient of x whole square plus, let me extend this on the side, plus square of the coefficient of y, which in the above equation pertains to a and b. The constant term pertains to c. So we shall see now an example wherein we will make use of all the three forms to which our general equation of the line is converted to. Let us see one example. Transform the equation of the line. Transform the equation of the line under root of 3 into x plus y minus 8 is equal to 0 to all the three forms, that is slope-intercept form, intercept form and normal form. So we'll put the solution first. First we'll convert our line into slope-intercept form. Slope-intercept form. Now we know that slope-intercept form is equal to y is equal to mx plus c. So we'll convert the given equation of the line in the same form. The given equation of the line provided to us is root 3 of x plus y minus 8 is equal to 0. So we'll keep y on the left hand side and we'll bring the terms containing x as well as the constant term on the right hand side. So my equation of the line becomes y is equal to minus of root 3x plus 8. So by comparing this to the slope-intercept form, we can say that the slope of this equation of the line is minus of root 3 and the y-intercept is equal to 8. We convert the same line into its intercept form. We all know that intercept form is equal to x upon a plus y upon b is equal to 1, where a is the x-intercept and b is the y-intercept, which the required line makes with the x-axis and y-axis respectively. Now, as we had seen in the last lecture, to derive the equation, the given equation in the intercept form, we had first brought our constant term to 1 by sending it into RHS. So we will do the same. The given equation of the line is root 3x plus y minus 8 is equal to 0. So we'll first send our constant term on the right hand side. So the equation of the line becomes root 3x plus y is equal to 8. Now dividing on both the sides by the constant term which is provided to us on the right hand side, our equation of the line becomes root 3 upon 8 x plus 1 upon 8 y is equal to 1, which can further be written as x upon 8 whole upon under root of 3 plus y upon 8 and is equal to 1. Now comparing this equation of the line with the slope-intercept form, we can say that a is equal to 8 upon root 3 and b is equal to 8, which means that x-intercept which the required line makes with the x-axis is 8 upon root 3 and the y-intercept which the required line makes with the y-axis is equal to 8. Now we shall convert the given equation of the line in the last, it is third form, which is normal form, the derivation of which we had seen few times just a moment ago. We know that I had provided you the steps to convert the given equation of the line into its normal form. The first step is shift the constant term on the RHS and make it positive. And second step is divide both sides by under root of coefficient of x square and the square plus the coefficient of y square. So first what we'll do, the given equation of the line is root 3x plus y minus 8 is equal to 0. First we'll send the constant term to the right hand side and make it positive. So we can write this form, this equation of the line as root 3x plus y is equal to 8. Now we had sent our constant term on the right hand side, but we see that the constant term after going to the right hand side itself becomes a positive term. So we did not change any kind of sign conventions pertaining to a constant term. We will keep this equation as it is. Now the second step was divide both the side by coefficient of x square plus coefficients of y square. So dividing both sides by whole of under root of square of coefficient of x plus square of coefficient of y. We can write it as under root of root 3x whole upon under root of coefficient of x over here is root 3. So we will write root 3 square plus coefficient of y over here is 1. So we will write coefficients of y square plus y upon, again we will repeat the same, coefficient of x square plus coefficient of y square is equal to, then the constant term which is over here is 8. We will repeat the same, coefficient of x square plus coefficients of y square. So this becomes under root of 3 root 3 square, that is 3, plus 1 square, that is 1. So 3 plus 1 is 4. So under root of 4, which will fetch me 2 as the answer, plus y upon, similarly under root will fetch me 2 as the answer, and this is equal to 8 upon 2, which can further be written as root 3 by 2 x plus y by 2 is equal to 4. Now comparing this equation to the normal form, we can say that cos of alpha is equal to root 3 by 2, sine of alpha is equal to 1 by 2, and the perpendicular distance from the origin to the required line is equal to 4.